Hey everyone, so now we're going to move on to a different type of projectile, which is going to be the horizontal projectile motion. Now, as I mentioned before, you want to make sure that you're differentiating the stuff that we talk about in this video with the vertical projectile questions. So I highly recommend that you, again, make sure you fully understand this before you move on to the next part, and make sure that you, when you read the question, that you identify what type of projectile. Now, a lot of these cases, what we're going to do is we're going to have objects that are starting with just horizontal velocity. So instead of it being thrown upwards, it's going to now be shot off to the side. Common examples would be things like shooting an arrow, a gun, or a cannon, rolling things off tables. All these are common examples of horizontal projectiles. Airplane drops are another one. Now, in this scenario, you can usually identify horizontal projectiles based off of, again, the terminology. So again, it's not being thrown upwards, it's being thrown, off to the side. Another way that you can identify these is that they always start at some initial height. Uh, Now, because the velocity is directed horizontally, we still have acceleration pointed downwards. So what we're going to end up getting is an object that will end up following a parabolic path. So that's what's going to make this a little bit different, is because we are going to have an initial motion in one dimension and then acceleration in a completely different dimension. One thing that's important is that velocity in this x direction is completely unaffected by acceleration. Now, we're not dealing with any problems where there's air friction, so the acceleration is only going to be in the y direction. Because x and y are pretty much independent of each other, what we're going to do is we're going to create an XY chart. I cannot stress how important it is that you make these XY charts. I don't believe that you can actually answer any of these questions without it, because there's going to be so much information and it's going to be very hard for you to identify which numbers go where. So you want to make an XY chart, and on the side you would write D, VI, VF, AT, something you should always write in, and I recommend writing in this order. And then from here, what you're going to do is start filling in some of the information. For example, in the X and Y direction, we always know what the acceleration is going to be. As long as we're on Earth, the acceleration in the X direction is going to be 0, and the acceleration in the Y direction is going to be 9.8. Now notice that I'm not making this negative 9.8. Again, this is something slightly different than the vertical projectiles. Before, with the vertical projectiles, I had to make the distinction that because velocity was going in one direction, acceleration was going in another, I made acceleration negative. Here, I'm going to make it positive because vertically it is only going in one direction. It's going down. It's not going up and then down. So I'm going to just make my life easier and make it so that the acceleration is positive 9.8. Another thing that I know is that because the velocity is only directed horizontally, there is going to be zero velocity in the y direction. So these are things that I automatically know. In fact, I will almost always know that there's going to be one term in the y direction is zero and one term in the x direction is zero. You should never have a chart that has more than one zero within a column. All right, if you have more than one zero in a column, you're doing something wrong. Then the other things that are usually asked are things like the height. So vertically, the distance is going to be what we refer to as the height. The distance in the x is sometimes called the range, or the distance from the bottom of the object or something. Like in this case for a cliff, it would be the distance from the bottom of the cliff. And VI in the x would be whatever speed it gets thrown at or shot at or rolled off at. The only term, I don't know if I write here. Okay, so because we know the acceleration 0, we also actually automatically know what the final velocity is going to be. It's going to be VI as well, because the velocity in the horizontal direction will never change. So this was the thing that I want to say, was that the only term, the only number that will ever carry over is time. Once you find the time in one direction, you know what the time is in the other direction. If you see me making my charts in class or in person, you'll see that when I do the charts here, I kind of always leave this open. So in all these, there's going to be a left and a right side, but for time, I leave it as one giant block because again, whatever time matches with these numbers will also work with these numbers. So that ends up being a very important thing, is that when you're solving these charts, you're going to end up using one side to find time and then use that time to find the other informations in X. All right. So we're going to start off, there's going to be two sketch questions. So pause the video, work on the cell phone, go over in a second. So I want you to sketch the three graphs for the horizontal projectile only in the X direction. So we're just looking at what's going on in the X. If you remember, I said that the acceleration in the X direction was 0. So I know that my acceleration graph should be 0. And this is where you always want to start. You kind of want to start with the acceleration because it tells you, it's going to help you find all these. I can use my curve linear constant 0 here, linear constant 0, acceleration 0. So the graph directly to the left should be velocity, graph directly to the rest is displacement. So I know that this should be a linear graph and this should be a constant graph. This makes sense since I just said before that the velocity stays the same. So whatever the initial velocity, it's going to be the same. And if I'm starting at 0, it'll go up linearly like that. Positive because this is positive. So positive slope, positive velocity. And that's what that's it. Try it again. Pause the video, work on a cell phone, go over in a second. All right, so again, we know that the acceleration is 9.8. If you want, you can make it negative 9.8, it doesn't really matter. Once again, if I did curve linear constant 0, acceleration is constant, my velocity should be linear, and my displacement should be curved. So my acceleration, I'm going to put the line up here. My velocity is going to be in the y direction, starting at 0 and increasing. And then my displacement, it's going to start up here and go up like this. Now, if you actually want to be a little bit more exact, because of the fact that this is technically negative 9.8 and doing that whole thing, the acceleration should be over here. The velocity would just be flipped to the other side. And then for this one, it would end up looking flipped like this. So it doesn't really matter. You just notice that it ends up being mirrored imaged and flipped over. But I would have accepted the red lines if you drew them in. All right. So here's the first real question. Pause video, work itself. We'll go over in a second. All right. So I'm going to make my XY chart. So D, VI, VF, AT. Putting in the numbers that I know that this is 0. I know that this is 9.8. I know that the initial velocity in the y is 0 always. Looking up here at the numbers, it's thrown horizontally, so VI is 20 in the x, and it falls 19.6. You want to use the context clues to figure out, what direction it goes in. Falling, that's a vertical thing. And they want to know how long it takes to get to the ground. All right. Now, if I look at this, I do also note the final velocity is 0. Now, sometimes it can be tricky to figure out which side of the chart am I going to use. Am I going to use the X side or the Y side? So here's a helpful hint. If you're only allowed to be missing one thing in the X direction, if you're missing more than one thing, it can't be used. So here, I'm missing two. I'm missing D and T. So I'm not going to be using the x side, I'm only going to use the y. Now again, I'm only looking at the y side, so I have a distance, an initial velocity, and acceleration. Looking for time, I'm going to be using the magic d. As I said in this topic, you'll really see why we call this the magic d equation. So 19.6 meters, this whole thing drops to 0, half 9.8 meters per second squared, t squared. Moving things over, dividing this by 4.9 and this by 4.9, making sure to square root, you end up getting that the time is 2.83 seconds. All right. Here's the next question. Pause video, work itself, and we'll go over in a second. All right, so making an XY chart. So time goes here, d, vi, vf, at. Again, 0, 9.8, and 0. I can always put these in if it's a horizontal projectile. The initial velocity is 200, so that goes in the x side, and height of 1.5. So in part A, I'm looking for this, and for part B, I'm looking for this. So once again, I'm missing two pieces in the x direction, d and t, so I can't use the x, I have to use the y. I have the same information, so it's going to be the magic d. I'm not going to write it just because it's kind of difficult with the mouse. But plugging it all in here, d equals VIT plus 1/2 AT squared. Again, dividing both sides by 4.9, I'll end up getting that the time is 0.56 seconds. Now that I have the time, I'm looking for how far it lands. So I'm looking for that x distance. Again, I'm going to want to use the magic d. Remember, you only have three equations that I want you looking at. Magic d, timeless, and the acceleration. Do not use the average speed equation unless it explicitly says average speed. So when you do this, you'll end up getting that the distance it lands is 112.4 meters away. By the way, I just want to clarify, I'm still using the magic d equation with the acceleration being set to 0. Again, you're only using the y side. Don't mix and match. It's very common that I see people start with some numbers here and then start using their y values, and they have a combination of x velocities and y accelerations. Don't do that. Cover up the y side if you have to so that you only look at the x, or cover up the x so you only use the y side. Here's the next question. Pause the video, work itself, and we'll go over in a second. All right, so if I make the chart, you'll notice that I don't have to go very far in making it. VI, VF, AT. Accelerations are 0, 9.8 respectively, and then initial velocity 0. This is 5. They're actually looking for the initial vertical velocity. Here it is. Sometimes that's all the question asks. It's going to ask for things that you may already know. So that's why I recommend put in the 3 things that you know always are true before you actually read the question. All right, for 30, pause video, work itself, and we'll go over in a second. All right, so I make my chart, d, vi, vf, at. Now I mentioned before that there's a lot of questions that require only one step to do, and that it was very rare for you to have to do 2 steps. Here is not one of those cases. This unit is actually notorious for having you do multiple steps. So here, if I plug in my information, it's going to look like this. They're looking for how far from the base, so I'm looking for the distance that I'm looking for in the x direction. But again, you'll notice that I am missing too much pieces of information. I'm missing d and t. So I have to take a detour. I have to find the time first, and then I can find this distance. So using the magic d, 0.6 equals 0 plus 1/2 times 9.8 times t squared. Solving this, you should end up getting a time of something. Unfortunately, I don't have it. And then from here, you would use the magic d again. This time I have an initial velocity. I'll use whatever time I had up there. Acceleration 0. And you should end up getting that the distance is going to be 0.84 meters. All right. Here's the next question. Pause the video working itself, and we'll go over in a second. All right, so making the chart. VI, VF, AT. Acceleration 0, 9.8. Initial velocity 0. Initial horizontal is 5. The time is 3. The final in the x is 5. We're looking for this. If we look, hey, we have all the known pieces of information. So again, using the magic d, x equals 5 times 3 plus 0. So it lands 15 meters from the base of the cliff. Again, you should start to see a pattern with how these questions are done. Almost always you're using the magic d, which is why I said it's always the first one that you should look at. And one of the two terms are going to be 0. Either the acceleration term is 0, the initial velocity term is 0, and you're pretty much asking, they're always asking a lot of the same stuff. Pause the video work itself, we'll go over in a second. Okay, so making the chart. I really wish I included this in each of my things, since my handwriting is getting worse. 0, 9.8, this is 0, this is 3, this is 5 still, this is still 15. This time we're actually looking for this number, the final velocity in the x direction, because they're looking for vertical speed. So I'm going to use VF equals VI plus AT. Final velocity is 0 plus 9.8 times 3. So the final velocity is going to be about 29.4 meters per second. So a little bit under 30. All right. Here, again, I don't even have to really make the chart too much, but I'll do it anyway. Zero, 9.8, 0, initial velocity is 5. Time here is going to be 1 second. So one thing I would say is make sure you're paying attention to things like this. Sometimes they'll give you like extra information. This 3 seconds in this problem doesn't matter. They're looking for the horizontal speed at the end. Oh, look at that. It's 5. Because again, I know that these two numbers are always the same. All right. Here's the next question. Pause video work itself, and we'll go over in a second. All right, so making my chart. Zero, 9.8, and 0. Shot off at 20 meters per second at a height of 100 meters. This is 20 as well. They're looking for time in part A and the distance in part B. So again, magic D, looking at the y side because the x side has too many missing pieces. So 100 equals 0 plus 1/2 9.8 times t squared. Time will end up being 4.52. Use the magic D over here. It's going to be 20 times 4.52 plus 0. And the distance here will end up being 90.4. All right. Here's the next question. Pause the video work itself. We'll go over in a second. All right. So making my chart. Again, you want to pay attention to the information that actually goes into the chart and which information doesn't. So when I make my chart, I still have 0 and 9.8 and 0. It says he starts with 40 meters per second here. So my final is 40 in the x. Total time in the air is going to be 5. Now it says that there's a patch of rocks stretching from the base of the cliff for 100 meters. And they're wondering, does he clear the 100 meters? So a lot of people might accidentally put 100 into here, but that's not what I'm going to do. I'm actually looking to see where he lands because I need to see if it's below 100 or above 100. Basically, this 100 meters is a reference number. It's not used in my initial calculations, but more of something I compare my answer to later. So I'm looking for the distance in the x. I have everything in the x column, so I'm going to use the magic D. X equals 40 times 5. So the distance he lands is 200 meters from the base of the cliff. So since the rocks expand only 100 meters, that means he does clear it, and he clears it by 100 meters. I think this will be the last question we do. So pause the video work itself, and we'll go over in a second. All right. Now, I mentioned before about how what happens when we start dealing with problems where there's friction. You will not have to do any calculation questions with air friction, but one of the things that you need to know are that when an object is experiencing air friction, it won't go as high, as far, or as fast as it would without it. So it won't go as far or as high. So starting at this same location, because regardless of if there was friction or not, it would still start here. It's going to still follow a parabolic path, but it's going to be shorter. So I'm going to draw it like this, and that's it. So you just make it where it starts at the same path, but it just lands a little bit sooner. And that's it. So there's 2 other questions in here. I highly recommend that you look at them. I'll probably post a extra set of questions later on for you to work on, but I want to stop the video here so it's not too long. If you have any questions, let me know. Otherwise, I'll see you later. Good luck and have a great day.